Starting from this week, we will start to go through how to use VCM, value capture model, to analyze real-world case. And today we'll work on digital product case. And this is simpler than the case we'll discuss next week. We'll use this as a basis and template to analyze next week's case. And I expect you to use the method approach in these 2 weeks cases. Just imitate them to work on your final group project for business model calculation. Okay. So before starting today's class, I will remind you, next week's case is very formal. It has all the detailed financial statements, such as business model and market share for the business model target at, and also how about raw material cost, okay, and production processing cost, and distribution, marketing. So it has all the detailed information when you start to work on your business model. And next week, I will spend 2 hours and ask you, some of you, or every of you, to do calculation on the board to dig out if we start to work on real-world business, has all the financial details, how do we apply value capture models? Is that clear? And we have all the clear financial projection for next week's case. And as you know, in your midterm project presentation, idea pitch, at the Ventec, George asked you to provide this information. So I will expect you to provide such information for all the financial details when you introduce IoT in the target industry. And when you apply this detail, how do we use value capture model to analyze it? So this I expect to see in your final group project presentation. And before that, we will spend 2 weeks work on how to calculate details when you have financial detail. Okay? So today we will work on the digital product case, and next week is ASF case, and I will ask some of you to work on the board here. And this week's lab is structural equation modeling. If you already start to find your supervisor for your thesis and dissertation, you work on marketing, behavioral marketing, or strategy, or entrepreneurship. I think if you are doing research thesis, 90% of you will use this method. This is standard method to doing survey analysis. If you do case study, that's the other story. But if you do survey, I think this standard tool. If you have chance to master these skills, this will surprise and impress your supervisor a lot. If you are doing our MBA here, trust me, if you really understand it, your supervisor will feel you are a gifted guy in his team or her team. Okay? So let's work on, we just work on the case. Now, we want to introduce digital product supply chain. Let me make some assumption. If you were an entrepreneur and you find out one way to create a new component, embed the IoT to sell to smart farming industry or smart transportation industry or whatever, or your phone, and you are a component innovator, so I want to start to draw a diagram for digital product supply chain. So that's you are an innovator. And you try to enter this industry. And this industry is with several original equipment manufacturers. So now let's say we have big 4 OEM in this industry. And in this industry, The first OEM you can think such as Foxconn in PC, so we have 40%, and OEM B we have 25%, and OEM C we have 15% of market share, and other 40, 25, 15, we have 5% here, and the rest of producer, they have 15%. So we can say this is a three-tier supply chains. We have supplier, we have producers in the second stage, and we have a lot of retailers. So just a lot. So such as we have a lot of stores or local branches to sell this digital products. So we have a lot retailers. If you have done supply chain management course, you know this is a three-tier supply chain. If we have all the financial details, how do we analyze this case? So let me repeat it again. Now you were an entrepreneur from this class, and you find out a way to innovate one component for this digital product, such as for smart farming or whatever, and your component with IoT sensor and gateway, and you can improve this digital product, and you try to enter this industry. And this industry has 4 major manufacturers in this industry and many small manufacturers. And all these manufacturers, they sell the product through retailers to final customers. So there are a lot of branches and local stores to sell product from these big 4 manufacturers. And now you want to see whether these OEM producers, they want to use your component innovation in their digital product. So that's our case. And your innovation for this digital product just cover a very small percentage of their components used in the product. And for the digital product using your component will be second generation for this digital product, okay? And retail segment, this retail segment is assumed will be grown up for 5% per year. And we start to make assumption for the current customers, we'll have around 10% they will change the old generation to generation products using your innovation. So that is our ideas. This background situation, and now we want to work on this case. The problem will be the market demand here. In order to do VCM analysis, we need to consider all the players. We need to give input. The players, the total value generated, and alternative value generated. Now we look at player part. We have innovator here, and we have OEM A to D. We also have other small OEMs, and we have retailers, and we have customers. I do believe you will face the same situation when you work on your case. Now, we want to simplify analysis. We start to see we have a lot of retailers and even more customers. Can we find out a way to estimate them without using them in the VCM? That's possible. If I can consider over 1 million retailers, I don't need to consider customers. So I start to think, okay, each retailer will face certain amount of customers, and the amount between the corresponding of retailers and customers will be quite certain, even we use new product. So if I can consider retailer, I do not need to consider customers. The reason is customers do not add extra value in our business models. The next problem is retailers. Retailer will just sell the product, the OEM, and you work together to manufacture. So retailer does not add any value in value capture analysis. So in the last week, we say, if we are doing analysis, but certain players, they do not have added value in our analysis. No matter you use your innovation to the digital product or not, retailer will not get extra value from your product, so we take retailer out. So now we can just focus on yourself, innovator, and big four OEMs, and other producers. And now, let's work on this case. If we think other retailers, they cannot add the extra value, and all market growth is from big four. You make this assumption. We'll see in the next page. And we will find our way to get this out by assumption, because they are not key players. Okay, now that's a basic story. I will start to give you more graphic analysis using the figures from the slides. Okay, so roughly speaking, we have two generation products. The first generation is a product without using your innovation of IoT. The second generation product will be the product using your innovation. So you are doing the component innovation. I can write down here. So you create one way to, you are doing the component innovation, new component, using IoT for second generation digital product. So that is your business plan proposal. You try to ask venture capitalists to invest in you to launch this product. And you will tell them they need to invest $1 million. And you want to check whether your innovation can earn more money than $1 million. So we start to analyze the first generation DP product without using your innovation. As usual, you are doing in industrial analysis or strategic management or operations management. Now, we want to draw the product focus line to analyze how different players appropriate value in this product. So from what we know, customers, each customer here, they will get utility for $350K. So this is a customer utility. When they buy your product, they feel happy. That value $350K. And the production cost for the first generation is $150K. And now we will put attention on here. As you are doing in the value analysis in strategic management, if I use customer value or customer utility minus production cost, and we will start to bargain between OEM versus retailer. The reason is we think customers, we have a lot of customers, and they do not have bargaining power. So as what we are doing here. So retailer will be able to charge $350 for customer utility. In this case, in total, we generate the value of $350 minus $150. So we have $200K to be appropriated between OEMs versus retailers. And now we want to check what is OEM price. And now, follow our assumption, because this product already exists in the market, and we know OEM actually get $50K out of $200K, and the retailer get $150K. With this appropriation mechanism, OEM price will be $200K. Retailers sells these product customers for $350K per unit. Okay? And the production cost is $150K. In this value creation process of first generation DP product, the OEMs and retailer will bargain for $200K range. And now we know the 50K will go for the OEM. So we want to calculate margin for OEM. So now 50 divided by 200, this will be 25% share of first generation DP product. And usually in strategy and the business model class, how do we explain this 250%? And we will say OEM has 25% margin ratio. And of course, this is different from alpha. This is not alpha. Alpha is a bargaining ratio between the pi minimum and pi maxima. And so far, I did not mention anything about pi minimum and pi maxima. I just use financial figures from its existing product market. Now, let me code this as beta. So I want to say the OEM has 25% margin ratio, and I code this as beta. We move to the new generation product. So now let's work on second generation DP product. This with new component you provide. And we start to make assumption about new product. We will argue actually your new component mainly for reducing production cost for assembling rather than increase customer value. So I will make assumption we have inelastic demand. Do you remember I tried to make assumption to simplify our analysis? I say the customers, they do not have added value in our analysis. So I make assumption that customer demand will not be increased too much using your new innovation. And I also say your product is not for increased their utility, and your product is mainly for reducing production cost. So the demand will not be sensitive to the price. Now, your innovation is mainly for reducing assembling cost. So now your production cost is only 50K, and we want to calculate the OEM price now. Do you remember we already calculated each OEM has 25% margin. So now I know the total value generated will be 300K, and I can use beta, that is product margin 25% times 300K, I will get 75K here. After I know 75K will be obtained by OEM, I know new or updated OEM price. This will be 125K. Retailer will get value for 225K. Now we compare the value creation of two different generation products, and we notice OEM now get more value than first generation, but set up lower price. In this way, this innovation is mainly for cost reduction. We compare the cost structures between two generations. This is a product without your component, and OEM charge the retailer 200K, and we use this information to calculate product margin for OEM. How do we know margin? Do you remember in any business model? We use profit minus cost times the flow rate to know the operating profitability in each business model. And usually in economics or finance, we call this as margin. Now we start to make the next assumption. If you start to launch this new component to digital product market, and we need to consider the switch ratio between old product to new product as what we mentioned on the slide. So we start to talk about the end consumer. They will switch from first generation to second generation with the rate 20%. How do we use this 20% information to calculate the market share for each OEM? We look at the market share data here. So this is existing market share. And we start to use Big Four OEMs' previous market share data to calculate new market share using second generation DP product information. We start to work on year one. T equal to 1 means year one. Now we have assumed all the Big Four OEMs will manufacture new generation DP. If we sum up their market share together, now their market share is 85%. 40 plus 25 plus 15 plus 5 is 85. And we want to use this switch ratio to consider how many the end customers will switch from old product to new product. So now we know we have the rest of 15% of customers. They do not buy the product from the Big Four. So we have 15% customers. They are buying from non-Big Four. So these 15% customers, they bought their product from non-Big Four's retailer. And this 15% will have 20% of them switch from old product to new product. And this create new market share for Big Four will be 88%. This is current market share for Big Four. Okay? And this is the rest of market share from non-Big Four. But non-Big Four, they do not use new product. So the retailers who sell non-Big Four's product, their product is first generation. And we assume there is a leak between the first generation customers to second generation customer. This leaking ratio is 20%. This is the way we get rid of customers and retailer from our value capture model. Do you remember we have how many players we have? We use such assumptions to get rid of customers and retailer in our value capture analysis. Now we do one more. We move to the second year. Second year the starting figure for Big Four's market share is 18.8%. And we start from the beginning of year two. Now the non-Big Four will have market share of, and the 12% will have 20% of them move to Big Four. And this figure will be 90.4%. And we can start to do all such market share change till year 5. Now we move to the most interesting part now. We start to make the customer demand for these 5 years. But you want to consider return rate for this new innovation, starting from the first investment year till the 5th investment year. And the first year, you assume there are 7 units demand. And we start to use some projection figures from financial analysts and industrial analysts with 5% growth and other diffusion rate information. So the marketing and sales team, they say the year 1, you will sell 700 in total industry. So the overall industry sale amount is 700 in the year 1. Year 2 will be 1,000. Year 3 will be 5,000. Use this information to calculate the input for value capture analysis. So we already have the players, only yourself, innovator, and the Big Four. and that's it. And other players are withdrawn and taken off using assumptions such as switch ratio for 20%. Now we start to calculate the big V. And we will have 5 years of big V. That is total value generated by using second generation digital product embedded your IoT innovation. So we start to use the information here. If OEMs can sell the new generation product to retailers, OEM will charge 25% margin. As we do in the value capture analysis, for big V, we always use largest value for all the value combinations. So now I want to make a way to calculate the big V. The capital V is the highest value for all the players to play together. And I already know the value creation from second generation is much larger than the first generation. The second generation product has 300 case value generated. First generation product is only 200K. And capital V need to consider all the players. And this is myself. I'm an entrepreneur who have this IoT component. If the big four use my component, and they will start to charge the margin of 25% times 50K to customers and 50K for production cost. And Big Four's market share is 85%. Now let me work on E. The first. This is T equal to 1. In the first year, the total market share of Big Four is 85%. I make assumption. Only Big Four can use ICE innovation. So that's why I do not consider other producers. If only Big Four can use innovators' innovation, in this case, now the rest of market share is 15% and times 20% of switch rate. Year 1's unit demand will be 700. I finished the calculation of capital V for year 1. And we can use different way to look at this value, this capital V's value. Part is flow rate. Is how many products I sell in the unit of industry. And here is price minus cost. Now we start to work on the little v. We still work on the first period, and now we have player. So innovator is play this game, in this game, and we have the top 3 OEMs play this game, but the smallest OEM, the OEM D, does not play this game. For this particular value chain, and how do we calculate their value alternative? Again, we use the OEM margin here. And we assume they are selling the second generation product. Why they are selling generation product? Because I, as innovator, I play in this coalition. Why now is only 80% for this value chain? So similar to our code we written now, we change to the value chain structures as 0110. We move to the next question. So now you are an entrepreneur, you ask for venture capitalist to invest you 100 million for this innovation, and you want to calculate whether this valuable or not. So you ask for $100 million investment, and you want to know this investment worthwhile or not. So how can we do it? We already have capital N, capital V, and little v. So using linear programming, we can get pi I minima and pi maxima for each player in different periods. So how do we calculate present value? On my slides, if you go to slides, you will see we already use our solver to get all pi minima and pi maxima. Now let's calculate present value. We work on the worst case scenario. If you are the innovator, you want to calculate your investment, so you want to calculate your project. So we start to do summation for pi minima across all the periods, and we times discounted rate. On my slides, I assume it's a 12%. Here is all pi minima, pi maxima. I use information there. I will get this value will be 2.739565 million. I use the same way to calculate the best case. The present value of best case for this business model. And after that, I want to calculate NPV. So NPV will be the present value minus my investment. That will be 2.273 million minus 1 million. For the return of this business model, the worst case will be 175 million. The best case will be 484 million. In that case, this is greater than 0. As venture capitalist, you should invest in this project. Is that straightforward? Your NPV of the project will get into the return range from 175 million to 484 million. I use pi minima across 5 periods to get the worst case of return in this business model. I use pi maxima to get the best case for the return in this business model. So I know the NPV of this business model fall into this range. And the worst case greater than 0. So if you are VC, you can consider invest in this project because worst case still greater than 0. Now, we spent a lot of time to specify value alternatives and inputs for this value capture model. After getting pi minima, pi maxima, using linear programming output, we can calculate the possible range for NPV. And we know this project will generate value for innovator from 175 to 485 million. However, I haven't said how much innovator will get in this range. So we start to work on the licensing fee. If you were an innovator and you want to sell this component to OEMs, and you definitely want to get some value from the OEM's margin. So we know OEM has 25% margin, and this is total value generated from selling the product. When OEM sells 1 unit, how much revenue sharing as innovator you should charge? So this will be the next question we are asking. The big four, they sell how many units? Do you remember? And in total, in the first period, there are 700 units in the market, and I will wrap out for the break. So here will be 88%. If all big four, they sell new generation product, and the market share will be 88%. So in the year 1, the Big Four can sell 616 units for new generation product. And pi minima is on the slides there. In the first period, as innovator, your worst case for getting the return will be $10.5 million. And now I want to calculate licensing fee. If I get pi minima as 10.5 million and divided total sales amount for new generation product in year one, that is 616. As an innovator, I should charge 70K per unit for the margin you create in the second generation product. The worst case, I should charge 17K here for the margin get from OEMs. Let's work on the best case. The best case, we will put pi I t 1's maxima divided by 616, and this one is 20.4 million. On the slides from the linear program output. So I will get 36.4K as the best case of licensing fee charge to OEM. Okay. So now I already know the final licensing fee in the year one. No, I don't say year one, I just put F here. I need to be more careful. This is not set. This is a range. So you need to use square bracket. Okay? Any question for licensing fees calculation? What is 34? Will I use the other color? What I'm doing here is I know there are 300K we'll get between the bargain from OEM and retailer. But now I want to put extra bargain. This is the worst case. The best case will be 36.4K. So I want to see now, I have the 75K here, and I want to know how much go for the innovator, how much go for the OEMs for this range. And now, as innovator, I want to choose a price from here. So I decided to pick out the price for 24.8K. So this will be the finalized licensing fee I want to charge. And it is between this range from pi minimum and pi maximum. We want to calculate innovators' margin ratio now. I know I will charge 20.8 from OEM to sell each unit of new generation product. And I also know OEM's margin is 75K. When OEM sells one product, OEM gets 75K. I get 25.8 out from there. So innovator's margin ratio will be 33. We start to see the product focus value creation diagram. Production cost is 50K. And retailer sales to customer charge 300K, 350K. And from what I did before, The OEM price is 125K. This is the retail price. The first bargaining in our model is OEM bargain with retailers. In this bargaining, OEM get 25% here. Retailer gets 75%. And now we move to next stage bargaining. And this is beta for OEM's margin. We have 75K. This is to bargain between innovator versus OEM, original manufacturing equipment manufacturers. And we know innovator's product margin is 33%. So we get 33% here. In the next round bargaining, OEM get 77% here. Okay, and 33% will be 24.8K. And OEM from selling each unit will get 50.2K. When you're trying to know how much margin you'll get, first you will consider after production cost, how much value you got from that supply chain to sell to customer. So in the first case, when the supply chain send to customer, they get 75K here. So supply chain get 25% of value creation. And 75% value creation will go for customers. Okay? So that's entire supply chain. When I work on here, I look at entire supply chain. But supply chain has 3 tiers. If I do not consider retailers already gone here. And I consider the other 2 tiers, innovator and manufacturers, which are OEMs. So the other 2 tiers, innovator, OEM, need to bargain the rest range of the value. That 75K will say how much go for innovators, how much go for OEMs. So that's why, and we calculate margin for each player. The next question will be, if I set up licensing fee in this range, the next question will be, will this charge from innovation satisfy feasibility condition and stability condition to ensure these value distributions are stable and feasible? That means they are equilibrium. We need to calculate this. We work on year 1. So this is the first year of launching your business model. And we want to calculate market share. S1 is the unit sold. We're 88% for new product in the first year, so we sell 616 units. From this licensing fee, innovator will get the value appropriate as 24.8, a licensing fee, times the total units sold out by OEM. And this roughly will be 15.3K. We use lesson logic. We can calculate realized value from this licensing fee charge for OEM A. We'll get 50.2K from selling each unit. So this is total units sold out in that year, entire market for second generation product. And we know in the Big 4, do you remember we set up assumption only Big 4 can sell second generation product? The Big 4 total market share will be 85% in the entire share. And if we check the slides, we say OEM A has 40% share among Big 4. So this will be ratio for OEM A to appropriate the share from entire second generation unit sold out. And this will be 14.5K. And we do one more for OEM B, and that will be is equal to 30.92K. 30.92K times 25% for OEM B's share among Big Four. We get 9.1K for realized value to OEM B if innovator charging 24.8K licensing fee. Yeah. So we do all this calculation. At the end, we can calculate summation across all the players' value. Now we work on first period. That will be 52K, 50.2K, and times 316. That will be 90.2K. And you can use Excel or R using all realized value here. We have all realized pi here, and we start to put all the value chain combination and start check. The first is capital V for feasibility condition, later are stability for each subset of supply chains. And if all the signs on each chains are correct, and we'll say the charge for this licensing fee is feasible, is it? So this business plan proposal is valid and can work on in the right way. So venture capitalists will think this business proposal is workable. Today you can see logic, no matter next week case and this week case, if we have financial report, or if we can find out any key figures in the case study to say, I want to set up this fee or the price, and we already get clue how to set up bargaining range. The key difference between VCM model and the traditional approach is, traditionally, you need to set up a lot of scenarios to calculate whether your business model is profitable or not, and you give one suggestion. And you may say there are several different scenarios, but they cannot really give the worst case and best case in a range as what we do. They can't. They only can get one point of value. If you get all the figures, you may change the demand or whatever, but you do not get a range. Only get one figure through very complicated calculation. But we are different from traditional method to analyze cases. We can analyze a range for the margin you get. I think that's quite useful.